Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on parabolas. So far in this unit, you have studied equations related to circles. Today, we will discuss the parabola. We will learn how to draw different parabolas and also how to write their equations. We have a lot of material to cover today, students, so let us begin. Earlier, you learned that when a slanted plane slices through a cone, one possible section that can be formed is a parabola. Parabolas are more common than you might think. A satellite dish is one of the most easily recognizable parabolic shapes. Parabolas are also used in the design of car headlamps and reflecting mirrors. Students, before we study the equation of a parabola, we must learn some important terminologies. Here is the graph of a parabola on the coordinate plane. V is the vertex of the parabola and has the coordinates HK. V lies on the line of symmetry called the axis. The axis of the parabola is the line y equals K. F is the focus of the parabola. The axis of the parabola passes through both F and V. F is located at H plus P, K. P is the focal length. It is the distance from the vertex to the focus. L is a line called the directrix of the parabola. The directrix is perpendicular to the axis. In order for this shape to be defined as a parabola, all the points on the parabola must be the same distance from the focus as from the directrix. Therefore, a point A on the directrix will have the coordinates h minus p, y. The last terminology to learn is the Lattice Rectum. The Latus Rectum is the chord that passes through the focus and is perpendicular to the axis. A parabola can appear in 4 different ways. It can have an axis that is parallel to the x-axis, opening either to the right or to the left. It can also have an axis that is parallel to the y-axis, opening either upward or downward. To begin, we will learn the equation for a parabola whose axis is parallel to the x-axis. Such a parabola is called an x-parabola. Let P at xy be a point on a parabola. By definition, we know that the distance PF equals the distance PA. Since the coordinates of F are h plus pk, and the coordinates of A are h minus py, we get this equation. The square root of x minus h plus p squared plus y minus k squared equals the square root of x minus h minus p squared plus y minus y squared. To reduce this equation, we square both sides, and then we expand the brackets. This can be simplified to the form y minus k squared equals 4p times x minus h. If the focus is to the right of the vertex, the parabola opens to the right. If the focus is to the left of the vertex, the parabola opens to the left. When the parabola opens to the left, the sign in front of 4p is negative. Thus, the equation of an x parabola is y minus k, the whole squared, equals plus or minus 4p times x minus h. Students, let us try an activity using this equation. A parabola has a vertex 4, 6 and a focus negative 8, 6. Write the equation for the parabola and describe its appearance.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us look at the answer together. Since the vertex is 4, 6, then h equals 4 and k equals 6. We know that the x-coordinate of the focus is found by negative p plus h. Therefore, since length cannot be negative, p equals 12. By substitution, we get y minus 6 the whole squared equals negative 4 times 12 times, in brackets, x minus 4. Therefore, the equation of the parabola is y minus 6 squared equals negative 48 times x minus 4. As the sign in front of 4p is negative, the parabola opens to the left. It has a vertex at 4, 6, and the focal length is 12. Next, we will study parabolas whose axes are parallel to the y-axis. These are called Y parabolas. Let V at HK be the vertex of the parabola. The axis of the parabola is the line x equals h. If the focus is above the vertex, the parabola opens upward, and the focus is found at h, k plus p. If the focus is below the vertex, the parabola opens downward, and the focus is found at h, k minus p. Just as in the x parabola, the directrix is equidistant from the vertex, and its equation is y equals k plus or minus p. Therefore, the equation for a y parabola is given by x minus h, the whole squared, is equal to plus or minus 4p times, in brackets, y minus k. Students, for this activity, I will give you the equation of the parabola. Name the vertex, focus, and directrix of the parabola. Then, sketch its graph.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I am sure you did not find this activity too difficult. The vertex is at -2, 6. Since 4 times p is 4, we can determine that p equals 1. Since the sign in front of p is positive for this given equation, the parabola opens upward, and f is found at h, k plus 1. The focus is at -2, 7. The directrix is y equals k minus p, so y equals 5. The graph of the parabola looks like this. Please compare your sketches and make sure that you have labeled the parts of the parabola correctly. Students, please take a minute to copy down this table. It summarizes what we have learned today about the properties of parabolas. Note how the equation, the focus, and the directrix change depending on whether or not the parabola is an x parabola or a y parabola. In the next lesson, we will move on to study ellipses. Until then, thank you, teacher. Thank you, students.